Good morning, everybody. Taking a look today at the beginning of our study of topic 6, which is systems of equations. Starting with just the general idea of what is a system of equations. Now, our title specifically says, what is a system of linear equations in two variables? You can have systems of equations that are not linear later in high school. You can have systems of equations that have more than two variables later in high school and into college. For our purposes, they will be linear equations and they will have two variables. Okay. So our two focuses today, how can I identify a system of equations and what does the solution mean? Okay. So here's the things I want to focus on with you. And I'm going to zoom in a little because it'll make it easier through these notes. The system of linear equations is two or more, we're going to stick with two for now, linear equations with the same two variables. Okay. So please write in the word variables, which is solved simultaneously. Now, I know that spelling can be a challenge. Please copy the word correctly because you are copying it. Okay. So we are solving these equations at the same time. We're using them to solve each other. A solution of a system of linear equations is any ordered pair that is a solution of every, in this case, it would be both, because we're going to have two, but the solution has to be a solution to every equation in the system. Also, it's the point of intersection of the graphs of the lines. Okay. Now, remember that coordinates are written in this format, x, y. This is your ordered pair. Now, I want to go over an example, well, more than one, but starting with the one that's in your notes with you. Okay. Now, in this example, you have a word problem. You have some pictures. Those of you who have me for an instructor know how much I love using pictures to help you. And a graph, which is another visual display. Now, I did want to point out that these variables are P and M. P standing for pencil, M standing for marker. Okay. So in a second, we're going to talk about how that fits instead of X and Y. But let me show you how I know that. This is the y-axis typically, the vertical axis. They marked it as M. If you want to make a little note that that's Y usually, it might help you with graphing coordinates. Okay. They made a little note that that's the x-axis is P. You might want to make a little note that that's usually the x-axis if that helps you graph coordinates. Okay. So let's just read the problem. One pencil and one marker cost $1.50. Two pencils and one marker cost $2. What are the cost of one pencil and the cost of one marker? Okay, so you went to the store and they rang the things up and now you're like, well, how much did the pencils cost? So they wrote equations. P for pencil, M for marker, cost $1.50. 2P for two pencils, M for marker, cost $2. This is a system of equations because you have two equations with the same variables. That's key item. Okay. So if you have two linear equations, same variables, you have a system of equations. There's your definition. Now, they ask in the problem, what if the solution is 0.5 for P and 1 for M, which they also show on this graph. It's where the points intersect. So when they graph this line and they graph this line, the exact place they ran into was this. So they're saying, yep, that's the solution to the system of equations. All that graphing we've done can pay off because it can show you the point of intersection, which is the answer to the problem. How do we prove it? Well, we simply put these numbers in, these values, into the equations to make sure they're true. So for this one, P is 0.5, M is 1, equals 1.5. Yep, that one's true. On this one, 2P, 2 times 0.5 plus 1 equals 2. Well, 2 times 0.5 is 1. 1 plus 1, true statement. If they're true statements, then we know it's a solution. If they intersect on graphing that's done well, we know they're an intersection. That is the solution to the problem. So all we're doing today is identifying what's a system, what's the solution, and what does the solution mean? The solution means that now we have the values for P and M, or X and Y, or whichever variables we're using. Now, I also wanted to go over with you, how do we know if it's a system or not? So, example right from Savas that we often use. I already filled this one in. It's not a system of equations, because first of all, it's not an equation, it's an expression. I see no equal sign and no balanced value. Okay, so it is not a system. This one is not a system. Okay, it is probably a linear equation. It has an equal sign, it has two variables, but it only has one equation. This one is a system of equations. Okay, they both use X and Y, and it's two equations. Okay, I am going to tell you that this one is a system. It's just wonky because one's a straight horizontal line and one's a straight vertical line. They do intersect. It is technically a system. It's not something we would give you. Okay, so that is how you know that it is or it isn't a system of equations. This one is a system of equations. They both use X and Y, and it's two equations. Very simple equations, but they are. Okay. So I'm going to ask you to go do your homework, do your try problems. I cannot wait to see you in class again. Once you've tried this a little bit and done whichever assignment, please bring your questions to class. We want to help you and can't wait to see you.